Hello, people of the internet. Welcome to this Chill Monday stream. Do let me know if my audio settings aren't good. Actually, let me know either way. Can you hear me all right? Is the volume okay? Is the music too loud or too low? Or whatever. But welcome, welcome. I wasn't originally planning on streaming today, but a few things came up in last night's stream. We worked a little bit on the gripper truck. We have one here in the scene, this guy. And I realized some things here when we were actually tweaking this guy's AI. That like, okay, they took some interesting paths around the level. And I kind of realized that, okay, my nav mesh is a little wonky in places. And also realized that I don't really have any tools to fix this. Is this Roblox or your own custom engine? This is my own engine, nothing to do with Roblox. Nothing to do with Roblox, no. Right, so in here, for example, you can see the nav mesh here. You can turn it on and off. We have a few nav mesh sort of layers. But we're talking specifically about this junction here, right? So you can see these colored areas on the nav mesh that represent roads. And if you have a car that's sort of like driving around along this road, like this, and then going in this direction. The way that these roads are kind of set up means that it wants to kind of drive it, rather than just driving straight, as would be sort of the natural thing to do here, right? Just going straight like that. They kind of want to stick to the AI roads, because the AI roads are sort of scored differently, right? And so it takes this weird sort of wonky turn here and then like follows that like dirt road. And that's an issue. It's not a very big issue, but it's it can be a little weird. Why are the middle of the roads not nav meshed? Now it's like to show what you mean here. Like these red areas here are the nav mesh. Are the roads, are the nav mesh roads, right? They're just nav mesh areas. Then you have this one, which is actually technically also a road. It's a so-called minor road, and it has a kind of an unfortunate color for this. But it's almost sort of like gray. But yeah, it's a different area. And we can see how these things are done. They're essentially just splines that kind of like run around the entire level here. So you have these things that sort of specify how wide an area can be, and you can sort of paint these guys. So this main road goes like all the way here around the refinery and sort of like back here. But again, we have another place here. It looks like this, which is a little funky. Like, let's turn off the nav mesh for a bit. If someone comes driving along that smaller road and wants to drive here, right? The way that this is now set up is that like it essentially like drives along either of these paths, and then comes here when it should really just like drive straight. So that's a bit stupid. But yeah, I don't know what you mean by not nav mesh. Everything is essentially nav mesh. You can see the the sort of boundaries of the nav mesh here along the cliffs. Occasionally you get these kind of places here where like the nav mesh is here, it's just kind of like poking through the terrain is kind of poking through it a little bit. And you can sort of rectify that by just adding an offset to the nav mesh, and you can see that it kind of fixes some of these issues, but that can make it a little difficult to read sometimes. Hey, what is the game engine name? It's called Basis, and it's not open source. It's not actually available yet. But the game that I'm building using this thing, which is actually already playable, if you visit the Discord, you can play Pre-Alpha 1, and in 1 week from now, the 7th of July, I will be releasing Pre-Alpha 2 for this. And my plan is to make Pre-Alpha 3 moddable, and when that happens you will get access to parts of the engine. But no, it's not open source. It's actually not available for general use because I'm trying to make this game and just make this engine kind of like along as a byproduct of that, if you will. Rightio. Anyway, to keep a long story short, what I sort of need to do here is be able to specify polygons here on this terrain that would allow me to like easily map out this whole area as, you know, belonging to this minor road here. Same thing here with this junction here in the middle. Because this is made up of just 3 splines, you can see the splines here. You can perhaps even see them better from on the ground. 3 splines here. In the middle we have this wonky looking place which is fully traversable, but the AI doesn't really recognize that as being a road, right? So if it wants to drive straight, it kind of has to like go past this thing on either side and then continue like that. So again, I would like to make it so that I can map out this triangular area here in the middle as a nav mesh area of some type. That's kind of the idea, and we will do that today. We will do at least part of that today. Has you made everything, or did you use open source stuff for this? I used quite a few pieces of open source, yes. I used, among other things, let's actually play the game. I think we have quite a few new people in the stream today. Welcome everyone. Let's play the game a little bit. Let me show you what it looks like. Right, actually let's start it a slightly different way. Let's go via the main menu, and that way we can actually launch the campaign. So I think I have the music turned off. Kind of don't want the music clashing with the stream music. Right, let's see. Hey Jake, I'm using Recast, yeah, sure. I don't think I've ever been here, I'm not quite sure who you are. Well, my name is Sebastian, I'm a game developer by trade, and Madrigal is kind of like my indie outfit. And I'm making this game called Traction Point with completely self-made tech. So, welcome, if that sounds interesting. What did you use to make your editor? Let's get back to that in a little bit. I'm gonna launch the game here, and if you haven't seen this before, I'll show you what it's about. This is actually probably, I think this is my 75th stream, so I've been doing this for a while. let's just say. But I did brand this stream slightly differently, specifically because I'm thinking we'll be doing specifically like engine development today. Anyway, this is a very early version of the game still. There's, for example, there's no voice acting yet. But the idea is that this is a car game, sort of like a puzzle exploration game. You have a few vehicles at your disposal. You have this really huge one over there called Mother, which is like this massive vehicle, which can, among other things, can lift other vehicles. Just have it move here, and you can actually play as the Mother as well. And then you can do things like use cranes to lift other vehicles. This sort of thing. See if we can actually... Let's engage the handbrake here. That makes it a little easier to play. Right. So we can lift this guy, and we can, you know, we can load him aboard if we want to, or we can indeed just like lift him somewhere else. Let's maybe reset the crane here while we are driving. And sort of like the idea of the game is to kind of like a sci-fi road trip, if you will. And if you join the Discord, link in the description below, you get to play an early version of this. And 1 week from now, you'll get to play a new version, which is what I'm working on right now. So this is kind of the game, and let's see if we can demonstrate sort of what I was talking about earlier. So if we drive here, and we put down the scout onto the ground. So off you go. Bye bye. And then we actually kind of back away a little bit. And so one of the things that you can do here is actually like talk to your buddies over the radio and ask them to do things. So if you stand here and we ask the scout, hey scout, move to us. Let's activate free camera here, see how it drives. You can see that it sort of like goes to the left and then it kind of goes back. Like so it does that kind of thing. You can see here on the like tire tracks. Like why did it do that? What's that about? And of course the issue, like I already showed you previously, if we draw the nav mesh here, you can see that, like, well, you can sort of faintly see the tire tracks there. It tries to follow the road because it wants to stay on roads. And then here it actually kind of goes back onto this other sort of minor road here and then drives along that. When it could instead just have driven, you know, straight. And that's kind of just like because of how the AI nav mesh is set up there. Right, let's see. And same thing goes for this other vehicle as well. It has a slightly different nav mesh, but the rules are kind of the same. So we want them to just like drive straight, of course, here, if this is actually the case. That you want to go straight over that junction there. Okay, right. So there was a question about the editor. How's this made? The editor runs a sort of a version of the game, and it does that for rendering. It also uses the game to run code in the editor if you have like components that you specify that you want to actually run them in the editor. And the editor itself, like this application, is a C# application, so it's a very, very classical Windows Forms C# thing. You made this all by yourself? I did. Yes, over a period of about 15 years. There's a video on the channel if you're interested. Maybe check it out after the stream, where I go through all kinds of small little things that I've made with this engine over the past 15 years or so. So yeah, it hasn't been made overnight, but over the past 15 or probably 16, 17 years at this point. But this is the first big game that I'm making with it, so still relatively unproven after all this time. Anyway, now we kind of know the background for what we're trying to do here, right? So I was thinking, okay, how do we actually easily just add a tool that allows us to specify, like, let's say we want to specify this area here as being part of this minor road. So you get sort of like a triangle piece here and another one here in the middle. And I think I have a sort of a plan for that actually. So let's shut this down. No, we don't want to save. And let's open it up. Let's open up a slightly older project that I have made with the same engine, but it's a different game actually. And we'll open up, I think it's that one. Right. This is the white box area for another game. It's very similar in many ways. It's also a car game that I have sort of on hold while I'm making this other one. How about the game? Well, what do you mean? What do you mean, how about the game? What was the motivation behind using both C++ and Zig in the same codebase? That is very simply the fact that like C++ is very complicated at the best of times, and Zig is very simple, and also much more modern and like, you know, it supports modules and really easy and powerful compile time code execution, these sort of things. And yes, I know that C++ supports modules, but like in practice it doesn't. Almost no one uses them because they don't really work in a like general sense, especially if you have lots of middleware and things like that. And C++ templates are like super complicated compared to Zig comp time. So I wanted to try to make a game with Zig, but I still wanted to actually use this game engine because, like I've said, I've had this for quite a long time. So I've just wrapped it so that I can write my game in Zig and still use this engine. Right, I'm gonna answer your questions in just a little bit, but I'm gonna show you what I'm gonna attempt to do today. And I say attempt because this is like not rehearsed or anything like that. This is an older game. I think we can probably actually run this. Okay, no, we can't. We can't. But let's still do it. I think I know what the problem is here. I just have stale data. If we get rid of, like, I think that one. Now we can probably run it. Oh, very loud. Right, so this is an older game. You can see it's a little similar to the one that we're making currently, and this is a white box level for this game. This game actually has like combat and things, so we can, let's see if I can remember how this works. You can actually shoot with this. You can shoot like grenades and all sorts of things. Nothing is finished, of course. It's just like white box stuff here. But the idea that I had for this was to be able to set up patrolling routes for you know, enemies in this world, and I did that using something called editor state. So normally when you have, you know, when you have an editor tool, maybe you have like the terrain editor tool, for example, you can raise or lower the terrain like this. or you know, you have the movement tool. So if you select that one, you can just move this thing around. All of that. All of these things are sort of like bespoke tools that are part of the editor, and so the editor needs to know, okay, we are now in the movement tool, or we're in the scale tool, or we're in the rotate tool. You know, all of these basic things. What if you just want to create a tool directly on the runtime side without having to actually modify this editor thing at all? And oh, that's a good question. Is the editor UI made with ImGUI? It's made with ImGUI among other things. Let me demonstrate. So I had an object type here that I prototyped something with, and this has actually only ever been used for grass painting. We're going to try to use it for another thing today. We have an object that we add to the scene, and click Edit State. We can see here, ImGUI. ImGUI is happening. So we are now editing this guy called the circuit map 1. The editor has actually no idea what is going on. The game itself has sort of injected a new tool into the editor. And so because this is all C# and the editor has no idea what we're doing here, we're drawing the UI here with ImGUI. And what you can do here now is just like shift click on the scene, and you can add these points to the scene. If you're happy with the thing, you can click this accept button, and the stuff is stored there in the scene. And again, the editor has no idea what these even are. It just renders them. But I realized here that actually what we do here is kind of similar to what we want to do today, because this was used to, like I said, or the plan was to use this to set up patrolling routes. So you can just click things like this, and it creates sort of like a patrol route. And then you click this, and now you've sort of finished with the shape, right? And then later on you can go in and modify these guys however you want. And it creates this kind of shape here on the ground. And this is kind of like almost exactly what we need, right? For that nav mesh issue that we were looking at. Now this thing doesn't actually work currently. Like, this is not used as a patrolling route, and I actually realized that like the delete button doesn't do anything and things like this. But I was thinking we would take this code and like repurpose it for the nav mesh stuff, right? Then we can get this this nice polygon shape here, and then we need to hook it into the nav mesh. That may or may not happen in this stream. Let's see how far we get. Right, let's answer some questions. How about the game? How long did it take me to make the game? If you're wondering how long I have been working on this current game, this thing, I think I have been working on this for about 2 years. I think it will be 2 years after the summer or something like that. Is for this game. And I'm hoping to release this next year, so it should be like a 3.5 year, something like that. How did you set up your viewport? Is it a placeholder control in WinForms? The game uses a handle. Yes, it is exactly that. It is exactly that. It's a panel control, if I remember correctly. This thing. This is not something you could do with all windowing frameworks, but you can do it with WinForms because it is Win32. So the controls have their H-Wind handle, and then I just render to that. Very simple. I'm trying to come to terms with the fact that I have both C++20 and Rust in my code base. Yes, I can imagine it not being very, very simple. And I can imagine Rust being kind of opinionated about what you can and cannot do there, while C++ just wants to get on with life. So, so good luck with that. Looks very cute. Right hand side is very WPF form, top left is very cute. Okay. I never used Qt for anything, but I believe it's pretty powerful. Anyway, so this is the thing. This whole circuit map system is made up of 2 classes, and we're gonna basically copy paste these from this other game, this thing called Slide. This is sort of like a project name. I'm gonna copy paste them into the core engine and make them a part of the NavMesh system, right? Sabed, well, thank you. The fact that you answer questions and transparent is something I appreciate. Absolutely. I mean, if I do something super critical, if I work on something super critical, I don't do it on stream, right? If I stream, it's what I've been saying to people like over the years when people are like, I apologize for derailing the thing and asking so many questions. It's like, no problem, just ask away. If I'm on stream, I'm kind of like available to you guys. It might mean that I don't get my stuff finished that evening, but hey, if I need to do something super critical, I'm not going to do it on stream. So that's completely fine. I'm using Qt for most of my internal tooling. It's a piece of shit, but it's a lovable piece of shit. Yes, I understand exactly. I mean, you wouldn't believe your eyes if I showed you what I had to do to support these skinned. Actually, you can see it a little bit too. It's a little too close for comfort there. These skinned scroll bars in WinForms. I 100% understand the lovable piece of shit concept. So yeah, I feel you. Picking a UI when doing anything with C++ is something I found troublesome, I guess. Trouble with, yeah, because it's hard for me to tell which. Right. Absolutely. That is kind of why I'm just stuck with WinForms for so long, because like Microsoft doesn't even know which one they want us to use anymore, right? It's crazy. They had WPF. At some point they had like Silverlight, and then they had Maui, and Maui is like nowhere near as usable as WPF or WinForms or whatever. I'd like to switch away from this to something like Avalonia or whatever in the future, but like, yeah, it's a hassle. It's a hassle. I just do everything in ImGUI. That is kind of what I would probably do in the future as well. Yeah. Yeah. To be honest. I kind of don't like XAML. Right? I'm impressed with what they've done with Avalonia, but I don't like XAML. I don't like the XAML workflow. I know some people really seem to like it. I don't. And so, you know, you kind of want to, you should at least kind of learn that and get familiar with it if you're going to use Avalonia. So that's kind of one reason why I don't necessarily like it so much. And then ImGUI is like super nice for certain things, but I wouldn't necessarily want to make like the whole editor with ImGUI or IMGUI or whatever you wanna call it. And like in a previous life, I just used WinForms as I used to work on like non-game things, so that's kind of what I knew. So I just went with that. Rightio. Okay. So my plan now for today is we'll take those 2 components. I'll show you them in a bit. The circuit ones. We'll make copies of them, and we'll add something called. I think I came up with a name for it already, but I don't remember anymore. So we have NavMesh area, and we have NavMesh area. That's path, right? Let's make that. Yeah. NavMesh area, NavMesh area path. These things. And so if you have the main NavMesh here, for example, if you know that a certain area of this should be marked as like a road, for example, you can just add a NavMesh area here. do believe these are kind of tricky to see on YouTube. I apologize for that. But maybe you'll manage. So let's just say that we want to have like a portion of this that like extends out there onto the grass. We can set here that, okay, this is an area of type, there it is, road, like so. And then we just do nav mesh main, and we rebuild the nav mesh. And that means that that area gets marked as being of type road. Yeah, first time we do the nav mesh exporting, it takes a while. If you don't do any changes to the level, it is then faster, but it kind of needs to like export the entire level into, or not the entire level, but the parts of the level that the nav mesh affects the nav mesh. It's a little annoyingly slow. Like so. So now you can see that, okay, now we have this thing here actually represented as a road. So we already have the logic in place to take like an arbitrary road or an arbitrary area and mark that as a road. So we should be able to use the same system for this new polygon stuff. All right. And to be able to use these as like components here in the editor, let's redo that. So this thing has, click the info here, you can see here that this thing has a basis nav mesh area component, which allows us to like specify the type and size and all of that. So we'll want to have something similar, something that kind of works like the circuit map did in that other level we looked at. And so how does that work? Let's go to, so this is like where I essentially write my Zig stuff. This is the game code. It's all in Zig, and VS Code, and then Visual Studio is for well, for the older games that aren't Zig, but in particular for the engine and tools. Let's close some of these things down. So I'm not gonna actually make this larger now because it just makes it much trickier for me to work. So hopefully you can view this on a somewhat large screen so that you can see what's going on here. Maybe I'll enlarge something if some of you ask for some specific part, but I'm gonna try to get this done today. So let's see what happens. So this is the circuit map component. And you can see that it's a namespace slide. A slide, as I mentioned previously, is the project name for that older game. So this is actually like a game side component. So it derives from game object component, circuit map component. We need to specify some stuff here to actually make this like a proper component. Create, destroy, draw editor. What is this actually using messages? It is. Okay. This will be interesting. Export level. This is the thing that actually allows us to bring things like custom data, essentially binary data, into the game runtime if we need to. We won't actually need that for this thing because these nav mesh area, polygon areas, or whatever we wanna and whatever we end up calling them, they won't actually bring in any data into the game runtime. The only thing that they will do is produce a polygon that will be consumed by the nav mesh there in the editor, right? Then we have serialize editor state, deserialize editor state. So when we have all of those points there on the ground, those things are actually saved to JSON. And yeah, we'll look at the editor data in a bit. Reset editor state and editor state mode changed. Yeah, we're gonna have to implement all of these, but I think they're basically taken care of by the circuit map stuff already. And then we have some stuff here that actually like add points, move points, update editing window. Right, you can see this is just ImGUI code. And here we have three modes, points, circuits, and testing. In the new system, we will have points and then probably polygons. No testing. This is very, very basic code. I'm not trying to be fancy here at all. So it's just like a bunch of ifs and elses. Right, we need to keep track of mouse X and Y. It's actually like, let's look at that thing again. Right, so if I go here again, let's go here to the same place. And add again one of these circuits into the thing. So now if we click edit state, first of all we go into like editor state mode. We can see like a very crude text here: editing base circuit map 1 circuit map. That's the full name of this component that we're editing. You can actually see that we can't do anything in any other mode. Like, it doesn't matter if I try to, you know, go like, okay, I want to go into scale mode. Nothing gets scaled because we are in the editor mode for that circuit map. Oh, haha, that's not good. Yeah, maybe we shouldn't do that. Clearly I have some bugs here when it comes to like this edit state, like boundaries. Like I said, this has only ever been used for one thing, even though the system is probably like 3 years old now. Anyway, when we are in the editing state, no matter how much we click on these other objects, we can't select them, we can't move them, we can't really do anything. The only thing we can do is move the camera around in the editor, and then we can issue like mouse clicks and key presses and things like that, and they go all straight to this circuit map component. So if we hold down, like I said here, with a hint, shift left mouse button, we can add new points like this, and they get added into or onto whatever kind of hits the ray. So we do ray casting here into the scene. And that code we can actually probably see if we go into add point, right? Yes. So we get the editor camera, we get the render scene, we get a pick ray, and then we cast that ray into the scene. And if we get a hit position, hit point is just a basis vec3, then we add the point to it. So that is what's happening when we click here. Just add more points like this. Move point is kind of like the same thing actually. Again, we get a pick ray and we cast it into the scene, but we just call move point instead. So that should be pretty easy. Right, mouse X and Y, that's kind of self-explanatory, I hope. Yeah, we actually use those. And selected in editor. Selected in editor is sort of like, I think it's used if it selects something else, it doesn't draw them. If we select it, it draws them again. Just so that we don't get like the whole screen full of like overlapping things if we don't want to. And then this is a so-called property map, which is currently empty. You can add stuff in between these two things. The property map specifies things that go here in the inspector. Kind of like if you're in Unity and you create like a public variable, it automatically gets picked up by the inspector, if I remember correctly. But that's not the case here in C++. So the terrain carver here has like a geometry component, and it has like a bunch of things. These are all laid out in a property map. And that is where we can add things like, if we add again one of these nav mesh areas here, this thing actually has a boolean, draw path when unselected. So if that is true, even if we select something else, we can see that it's still getting drawn here. We unselect that, now it's not getting drawn again. Things like that we might want to add. But we're going to copy this guy, make a copy of it, and move it into the core engine proper this time around. What are we using here? We're using only things from the core engine. So core, messages, input, renderer, math, UI. And yeah, we're using straight up imgui here to render the editor. That's cool. Right, you can actually have multiple circuits here in one of these things. That's something that might be kind of handy for this as well. Like if we have all of these points, right, and we go into edit state again, we go to circuits, and click new circuit, and assign points. I think this is how it worked. Yeah, so that's now a circuit. We can maybe even, no, we can't actually change the color. Do one of these things. It has like a somewhat distinct color, right? That color, that color. So now we have three circuits here. Maybe that could be kind of useful to have multiple of these shapes all in the same component. I think that might be useful. And then of course we can undo and redo that. But we can only undo and redo at the level of like when you enter and exit those that edit state. Cool. Okay. So we can probably actually keep that open for the time being. Hey Nolrum. Hamburg calling. Oh. This is Espo responding. It's going pretty well. Decided to do a little bit of engine side stuff today, and we'll see how that turns out. I need to add a new feature to my NavMesh processing pipeline to get rid of some of the silly things that those cars made in yesterday's stream. Okay then. Right, while this is running in the background, we can't actually recompile it, but that doesn't matter. We'll handle that when we get to it. So let's go here to slide. Actually, before we do this, one more thing. You can see that this was one of the components, one of the classes that I spoke about that we need to actually modify. So a lot of the stuff that this thing does is it's handling this thing called the circuit map editor data, right? Circuit map editor data is also a class, but it's not a component. It's just a class of things. And this is where the actual data for this polygon is stored. So we have a point, we have a circuit. So this would, in our new case, this would be probably point, but then this is the polygon, and it has just an indices list and then a draw color. What else does it have? It has a list of the points and a list of the circuits, and then importantly, it has like all the rendering stuff here, because like these things are actually rendered using triangles. You can sort of see the tessellation here for these rings, right? And so it actually creates like a mesh that it then modifies on the fly to render these things. Some of these things here are just using debug draw, like these lines here are just like actual debug draw lines, and these selection boxes when I select a bunch of stuff here. All this is done using debug draw, so you don't need to like create any meshes or anything like that. But then the circuit ones are. And you can see this is actually kind of basic, because it probably actually only uses like two points to specify sort of like the width of this thing. But that means that if you have a case like this, the points end up like somewhere probably around here and on the other side, which means that it gets very thin actually, and then it gets thicker the more they are sort of in a straight line like this. But yeah, I think we're gonna use this as it is for now. It will, I'm sure it will be good enough for our purposes. Are you using recast detour for damage or rolling around? I am using recast and detour, yes. And I'm not paying for Havoc, and I'm not paying for Mercuna or Kynaps or whatever they're called. There's one more which I can't remember the name of. Yes, recast and detour all the way. And then if we look at the code for the editor data stuff, what has this thing eaten? This is really old code. I haven't looked at this for like 3 years or something. We have save to JSON and we have load from JSON. So the levels are stored in JSON format, at least the stuff that can be stored in JSON format. So things like textures and whatnot are obviously binary. But we will use this almost as is. Then we have some very basic bookkeeping stuff. Adding a point. Target point bounds. Yeah, then it marks the visualization as being dirty. Start assigning points to circuit. Right. We will use that as well and add a point to circuit. And then there's a little bit of logic here. I'm pretty sure we can just use all of this. Finalize circuit is probably like check for self-intersection. Figure 8 should not be allowed. Yeah, I was correct in that 3 years ago. It shouldn't. We probably need to detect that somehow, but that's not going to happen today, right? What is this? Update geometry. Right, so here we're actually going. There's probably like a create geometry things. Create visuals is right here. So what we're doing here is that we are creating a material with the transparent render pass. We're throwing some mesh vertex color unlit shader on it, setting up alpha blending, and then we're creating a material out of that material description. Then we're creating a manual mesh, and a manual mesh is like a mesh where you just tell it, I want this vertex format, and then I want this many vertices as a maximum, and then you just start throwing things into it. Out of the mesh, we create a mesh instance, which we can actually then place in the scene, right? And then we destroy the visuals, and then we update the geometry, and this is where we actually do that thing where we throw things into the mesh. And this is using something called the triangle lines, which just basically, that was the thing that I spoke about, where you have like a width of a line and want to draw it. So add the points for all the points, multi-line point. Yep, so that would be like these white guys, these things. If you select them, they become turquoise. And then we add the circuits. Again, we have a multi-point line that we add stuff to. An in-progress circuit, right? So when you select one circuit, select like the pink one there, assign points. Now it's like in a mode where it waits for you to click all the things that you actually want, like that, and then it becomes its final color. That's cool. Okay. So I think we can use basically everything here, at least almost everything. So let's make some copies of some files. So if we throw like slide onto the left, source, see if I can remember where these things are. I think they are in, is it math? No, is it AI maybe? Yeah, so here we have the circuit map editor data. And then the other one will be in the game components. And on the right we have the engine. So let's go into include AI. I'm going to copy the header there. And let's now give this a sensible name. So basis nav mesh. What do we want to call it? Nav mesh polygon. Nav mesh area polygon data. Something like that. Like this middle piece here, nav mesh area polygon. I think that is going to be the object name that you will be manipulating as sort of like the user of the system. So I think this name makes sense. Navmesh area polygon data. Let's drag that there to the side and go to source AI and do the same thing here. Copy this guy over. Basis navmesh polygon area data. Navmesh area polygon data. Almost. Actually, it's probably the other way around, right? It's an area made up of polygons. It's a polygon area. Makes perfect sense. Now that I think about it. Navmesh polygon area. And then we need to add the component. And so the components go in game object components. These are all the engine level components that we have. So nothing game specific, right? So we have like ambience controllers, curve paths, dynamic body transforms, kill planes, light map builders. We have all of the navmesh things that we're going to be adding to. Physics blockers, SDF shapes, sky spheres, that sort of stuff. Very sort of generic and multi-purpose in many ways. Let's see, what was the name of that thing? It was probably something like circuit something or other. Circuit map component. Basis navmesh I keep forgetting that name. I want to get it right. Navmesh polygon area component. I'm surprised most of those are from no earlier than 2023. They most certainly are from older than that. This is like the modification date. Yeah. Yeah, they have probably been modified, you know, as some sort of like mass modification when I've changed some API or something in 2023. That kind of sounds about right. Actually, I think I know what it is. I can even show you in a bit. Let's get this renamed first. At some point, these components took a bunch of parameters as the constructor parameter, and I changed it to be a game object component init component that then has all of these things. So I think that actually is something that would have touched on almost every component in the whole system. One thing that you can see that is like, depending on how recently I've touched a component or a class, is that if I'm using pragma once in the beginning, then it's a reasonably new file, or recently touched file. You can see here actually in this init file here, I have this old style include guards. Nowadays I use pragma once. It's actually like there's no compilers that don't support pragma once, and it actually tends to be faster in like really large projects. Not to mention it's just easier. So I don't use these anymore, but they're still there in like a whole bunch of different files in the project. You know, considering the industry at the moment, I feel it's good to have this kind of stuff as a lifelong project. Yeah, absolutely. Yeah, it's sort of like coming home to a messy home, right? you may be working on some other project somewhere else, and then you come home to your messy apartment, and this is kind of like my messy apartment. It's really messy, but it is it's my mess. So I tend to know these things, like, okay, this is a Pragma 1, so I've touched this at least recently enough that I've changed it from an include guard to a Pragma 1. I find this so fascinating to watch, watching someone with actual experience who knows what they're doing working on a large-scale piece of game tech. I could ask questions all day, but I won't want to distract you. Yeah, like I mentioned just maybe half an hour ago, and I know Nolram has... you've heard this before. When I'm streaming, you're free to ask questions. It's absolutely fine. I might not answer them if I'm too concentrated on my work to do that, but just ask away. Absolutely no problem. If a stream turns out to be mostly a question and answers session, that's completely fine. That just means that I'll have to do the work the next day or whatever. That's fine. Okay, so now we have the files there. Let's go into the most horrible thing, which is CMake, and actually add them in here. Someone asked me previously why I want to use Zig. There's one reason. Like, Zig has the most awesome build system and module system. And I know I don't really have to do it like this. I don't have to specify every file. CMake has functionality to actually handle that sort of thing, though it can lead to some hairy issues if you do that, if you just include everything in folders. So I tend to not do that. So basis navmesh polygon area component, want to add that to both the headers and the sources. And then we want to go into, I think it was AI. And yeah, like I'm not a fan of CMake, but it is kind of like a necessary evil working on a large code base like this to have some sort of project generation. Right, and these days I would probably use SharpMake if I started from scratch, but again, this project is so old that I didn't know about SharpMake at the time when I started using CMake, so. One thing I was curious about was your use of the C++ standard library. From what I know, most engines tend to not use it. I use a custom one. Was performance of the built-in one not a concern for Basis? It is a concern for it. But it's a concern for it mostly for the debug version. So MSVC standard library containers are notoriously slow in debug mode. And I believe there are some flags that you can fiddle with to turn off most of those checks. But it is a concern. Yes, that is why the debug version is so much slower than the release one. Like, it is unreasonably slow, unfortunately. Switching out the standard vector for a custom one would probably ease that a lot, because I especially back in the day I used vectors a whole lot. Nowadays I use static vectors if I can, sometimes even just like raw arrays. But there's a big amount of vector usage here. I also do use all kinds of, let's see, STL containers. So what do we have? We have vector map, unordered map, list, and queue. Not sure I use all of those. Then we have the old, at this point, sparse hash stuff. So we have the a dense one in particular. The hash map and hash set are pretty good. And then there's one that's called, this is Maltes Karupke. Probably butchering his name here. A very fast hash map that I've sort of slowly started using. I also use his sorting function. He has a very fast sort function, which is used heavily in the renderer. There's EASTL as well. There is EASTL, and I've looked at some point at EASTL to see if I could just pick their vector out of there, but it didn't look very easy to do. It kind of wanted to bring their whole core stuff along with it. And like, I should just, make my own vector. If I had infinite time, I would have done that already. I did write my own string class. I don't use stud string almost anywhere. I do have a few like type defs here for stud string. Actually, here we go. Stud string with my own allocator. But I do have my own string, which has a little bit of in-place memory. So you can have, basic string with just a single single character. So essentially the null character that essentially turns into a heap string, right? Because all the data needs to go on the heap. But then if you know that you're only ever gonna require 32 characters, you can just use the string 32, and that has 32 in-place characters for you. So you don't need to touch any allocators. And these things they fall back to a dynamic allocation if it doesn't fit. So the base, just create a basis string that's a 64 character string. But yeah, it's a completely custom string class. So I don't use like this stud containers and functionality just willy-nilly. I kind of just use whatever I don't have currently, and later on I realized that yes, I do believe, I haven't actually profiled this, but I do believe the stud vector to be the case, be the culprit there for the very, very slow debug build. Righty-o. Okay, let's see if we can find our new things here. So it was nav mesh area. No, it was nav mesh nav mesh polygon. Nav mesh polygon area data. So let's rename this guy. Actually, let's not rename it because it will most likely rename the other one. Maybe it won't. Let's see. I'm changing my mind here. Yeah, it does seem to realize that it's only those two. So nav mesh polygon area data. What? That didn't work. Okay, nav mesh polygon area data. And so I think we will actually like massage this guy enough to be, at least we'll get rid of the stuff that we don't need, and rename circuit into polygon in almost all cases, so that we have this sort of like almost like ready to go, at least for the editing. that makes sense. And then we'll tackle the component. So let's call this polygon. Polygons. Like that. Set selected polygon index. Circuit index, yeah, okay. That should all be good. I think. Actually, now that I look at this, it kind of looks like we don't necessarily need to do like a whole lot of adding. I don't want those with a big P. I need to make it small again. Yeah, we don't really need to do a whole lot here in this data. What was that previously? Circuits. And circuits is where? It's right there. Okay, there we go. All right, so it's that one. Polygon. Let's do the match case. Yep. And as for that name that we changed here, polygon map, let's not call it that. Let's call it nav mesh polygon area visualization mesh and material, like so. We had some circuit stuff here already, or still. Circuit. All right. And I'm probably gonna have to go in and tweak some of this stuff later on. But I think like it was almost exactly what we wanted already, so that was nice. I mentioned previously that the delete button there doesn't do anything, and this is why. Apparently I never implemented the deletion of the polygons or the circuits at that point in time. Let's make sure this actually builds. Yep. Does seem to do that. Okay. Good. So this should now work basically the same as before. What's that? Okay, some index debugging there. Let's see. Since the editor is in C#, do you use the standard pinvoke for communication between C++ and C#? No. No, I do not. Well, first of all, this game engine is very sort of, in a way, network-oriented, even though I'm not technically necessarily making a multiplayer game. I'm kind of keeping my options open. Even though I'm not necessarily making this game multiplayer, it is a client-server engine through and through. And so you can see here even like the circuit map thing here. We can see it. Oh, okay, that's actually not created on anything sensible. But if we select like one of these trees here, and we click on its mesh, we can see that this is created on the client, on the level editor, and in the asset browser. Select the transform. You can see that it's created on the client, the server, the level editor, and asset browser. So everything here has like the concept of living on the client or living on the server. And because that is the case, I need some way for the client and the server to communicate with each other. And they may be sitting on the same machine or on different parts of the world. They may even be sitting within the same process, of course, which is the case if you're playing a single-player game. But for that, I created an RPC system, which you use by essentially like, let's see if we can find something sensible here for that basis. RPC is right here. So the way that the game engine communicates with the server is via this editor app. So we have editor communications manager, which is actually sitting on the game side, and then we have the editor app, which is this, this C# application, this guy. And so if we look at the editor app IDL, interface definition language, which is something that I've just completely come up with on my own. It kind of looks a little bit like C++, in that you have these functions here. They don't have a return value because they are asynchronous, so they can't return things like in the standard way. They can return things though. I'm sure we'll see one of those in a second here. But they kind of look like normal C++ functions. You need to specify whether or not they are reliable or not, because we're running on like UDP connections. And of course in the editor everything is reliable. So specify this, and then this generates some code for you, and it can also generate C#, and that is why the C# side can actually can communicate with this. So if we look at this editor app IDL, we can go into the solution that has the tools. There's a super heavy solution. This is where like all the tools live. And so if we go in here, we can see the C# that this thing has generated for the editor. So the editor is right over there. We have RPC, editor app RPC stub. So this guy, API handshake. You can find it here, and it's a large switch case where like if it detects that someone is sending the API handshake, it knows that okay, it has an integer, which is this parameter here. It knows that is what will be sort of next in the stream of data, so you can just get that out of there, and then it will actually call the function on the target, the API handshake, which of course does something. And that is how almost all of my tools communicate. And indeed, just the game communicates with itself, in the sense that the client communicates with the server and so on. Here we have some things like out parameters, for example. Show resize terrain dialog. So the game can send this show resize or call show resize terrain dialog on the client, and it has 3 out parameters. This is of course not like standard C++ syntax here. And what this does is it actually takes these 3 pieces of data that you get out of this thing and generate like a callback function for it. So it looks completely different in the generated code. You can see here that this thing is actually just, it doesn't have any parameters here in the generated code. But then it does have, if we look for height map size, we should be able to find it. Oh, it's actually, it's here in the other, in the other one, isn't it? No? All right, the name can't actually be found. It's just called something like return, RPC return. Yeah. So what we will what we will actually find. This is not really relevant for you guys to know. Just for completeness sake, I'm gonna try to find it here. So this is a vector to int bool. That is, you know, that is the signature for this. And so that would mean that it generates an RPC return with a vector to bool, and these are just called out0, out1, out2. So when the thing has actually shown its resize dialog and it wants to communicate these 3 things back to the game, it will actually call RPC return, and you just pass them as these things here, and it will package the thing together. And like these tend to be kind of long. You can see that this is, what was this? Almost 1,000 lines. And you know, this is generated by the IDL compiler. So I'm not sure it's a preferred method. It is pretty cool though, in the sense that, like, you know, I have this thing here, my asset server. If we go into the game data, we find the game. You can see here's slide data. This is the data for the other game, the game that we took that circuit thing from. Here we have means data. Means is the code name for the current game, which is called traction point. Means is just the project name for it, essentially. And here we have all the data for the game. So if we go in here and we find like a texture, for example, it's got like means and vehicles and mother, which is the big yellow one. We can find mother's diffuse texture here somewhere. Spring diffuse, chassis diffuse, right? Here's mother's chassis diffuse texture. You can right click this guy and just go convert, and you can see that this thing picks it up. It runs through a conversion and converts it into probably like PC7 or something. Yep, PC7. This asset server knows where all of the data files are, and it knows that if we converts this chassis diffuse PNG here, this is actually the path that you can access that texture with in the game. Like, we don't use any like absolute paths, obviously, because like here it is sitting under D projects, basis data, means data, blah 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 blah. But that may not be the place where the actual players have it on the disk. So they need to use a different, like a so-called resource path. And this basis asset server is the one that like assigns these things to different resources, and also takes care of monitoring the data, monitoring these folders when you make changes to these things, and then you can like forcefully convert them just by clicking convert here. And the nice thing is that, like, if we run the game, I'm gonna bring this over to the side. If you look at this basis asset server window, when we run the game here now, you can see that we got client login succeeded, and that means that this thing is actually like getting all of its resources from the asset server. It doesn't necessarily load anything from disk directly. I mean, yes, it does in this case because it's running on the same machine, What this means is that I can serve all the assets from this asset server to like other machines on the network. Like let's say I'm testing out a build on the Steam Deck, for example. I just need the game running on the Steam Deck. I don't even need the data. I can have the materials auto update them or update them on the machine, have the asset server convert them, and then this thing just sends a ping to the game telling it, hey, this material was changed, or this texture was changed, or whatever. And it all works. And it's also, the reason I'm explaining all of this is that it also uses this same RPC system to do the communication, right? So that's why it's I like it a lot, because it's super sort of versatile. I can use it to communicate between programming languages and all of that. Just like you can do with something like gRPC or whatever, but much more lightweight. RPC is a mystery to me. I sadly know very little about network programming. Really need to learn more about it. Haven't found any good resources though. Blah, 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 blah. Reminds me a bit of Protobuf. Yeah, I'm not necessarily a fan of gRPC in the case of like game programming. It can be very handy if you're doing like web stuff. Like, God forbid you're doing some sort of microservices work, then gRPC can be very handy in those cases. Because it's almost like black magic. It kind of just works, which is of course scary, because then when it doesn't work, then you're like, well, where's the problem? But I do use it for some non-game projects. I also use it. I use gRPC for my little baker tool. Like I had around Christmas or well, during the winter anyway, I made like a system that allows me to bake the light maps for this level that we just actually played. And I made a small little monitoring tool which communicates with the server, which just sits in the background and continuously bakes light maps. And that monitoring tool actually uses gRPC to communicate with it, and it sends all the light maps and everything, the data over the gRPC. It works just fine. So, but making an RPC system is not very difficult. I would almost, like, if you're going to use it for game stuff, I would almost suggest you just make your own, because then you kind of know what it's doing under the hood. I'm not huge on having intermediary IDL. Understand that sort of thing can be necessary in many cases. You don't need to have an intermediary IDL necessarily. You can just write your IDL can be any of the languages that you use, right? My IDL is almost C++. This thing. I just kind of, I took away the return value, and then I added this special syntax here in front of this to tell. There's also like a master block, as it's called here, to specify more parameters. But I mean, your IDL can essentially just be C++. The RPC system can work exactly the same, regardless of what your IDL is. It is just that if you use, C# or C++ or something as the IDL, you need something that can read that. And so my solution was to make this syntax, and then I have a very, very basic little custom parser that reads this stuff. But if you're using like C#, which I believe you, Nolram, are actually doing, then I believe there are 100 different ways to parse C# that you can actually access, right? So you could even have C# be your IDL. You wouldn't necessarily need protobuf or this kind of IDL. You could just use C# as your IDL and then get like the AST, abstract syntax tree, out of that and use that as the input for your RPC compiler or something like that. Did look into enet before. I am using enet. Yeah, this thing is sitting on top of enet. So enet is good to know. I'm using C#. There's a bunch of RPC systems for it. Many of them use C# as an IDL. Yeah, I think, I mean, for something like an editor, if you're communicating with like a process from a UI application, kind of like this, then performance might not be your biggest concern. But if you want to use that RPC system to actually like synchronize the game state while the game is running, then you most likely want to have the actual RPC runtime be something that you fully control, right? Okay, let's do the component next. See if we can get that going. Just close those guys, and then we go here. We should have our new component, which is right there. Nav mesh polygon area component. So this should now be kind of simple. We don't want this actually to sit in slide, and neither do we want this to sit in slide. So we just want to bring all of this over into basis itself. And on the CPP side, we want to take slide away there as well. Right. And then since this is actually now in the core engine, we don't want to use those angle brackets, but quotes instead. So how long did it take you to make this whole engine? Well, I should probably start by saying that this engine is not finished. So it depends on what you mean by this whole engine. For the past year or so, I haven't really done a lot on the engine. I did switch my graphics rendering to use NVRHI, and I did a little bit of work on supporting WebAssembly for mods mainly. But other than that, I haven't really worked on the engine for the past year, right? It's been sitting there in the background. I've been working almost only on the game itself. So I have these kind of periods where I don't really work on the engine all that much at all, and then you know, I go back and do something on it. So it's difficult to say, but well, if you're interested in the history of this engine, you should go watch that 15 years with a self-made game engine video. I'm sure you can find it on the channel. 15 years with a self-made game engine is what it's called. And I think in there I say that I started the engine, if I remember correctly, in about 2010. And I even go back and do a little bit of archaeology there to try to play some of those older prototypes. This editor, this thing, this turned 10 years last year. So 2014 is when I actually started working on this editor. So that would mean that I had been messing around with the engine itself for about 4 years, if you know, from 2010 to 2014. This engine is 15 years old and it's the same source code, or did you restart it many times? Yeah, there's the core is the same. The core is the same. I've done a lot of things over the years that I've thrown away. Just as an example, just take all the renderers that I've you know, written and supported. So I've written 2 Vulkan renderers for this thing. I've written one metal renderer, one D3D12 renderer, and at least 2 D3D11 renderers, and I've thrown all of them away, and now I'm using NVRHI, and my life is better in every way. We started engines at around the same time. Hey, that's cool. So I know you're making a short Odyssey with your engine, but have you made anything else? I have like I even have some like smaller game projects that I didn't show in that 15 years video that I made with this. I have just an enormous amount of things. Righty-o, folks. Now we're gonna quickly get this this component working. It shouldn't be very long, and we can start actually messing around with this thing. So navmesh polygon area data. This should also be in basis, and I think I tend to actually expose these things. Yeah, basis API. I tend to expose these things to the outside world. So the core engine is a DLL, and thus, if you want to be able to actually poke at some of these things from the outside, you need to actually add this decl spec DLL export thing there. So we're gonna rename this nav mesh polygon. How is polygon so difficult to write? Nav mesh polygon area component, right? How do you feel about Unity? Have you used it before? Would you consider using it again? I have used Unity before, yes. I've even worked professionally with Unity for about a year. And I kind of like Unity as an engine. I've even been at Unite in Seattle. That was in 2014, the same year I started my own editor. At that point I was very heavily invested in the Unity ecosystem, but not for my own stuff. So yeah, I've used Unity. Unity is pretty cool. I would be pretty terrified of using Unity these days, what with their recent shenanigans on the like licensing front. That is kind of how I see it. Game object components. No? Game object components. Oh, it's lacking the basis word there. Yeah. Yep, that's it. So I tend to like just as a way to easily see what is part of the engine and what is not. I start all of my core engine. Oh no, OBS. What have you done? My internet connection has been pretty solid for the past few streams. I'm hoping that remains the case. Some of you know that previously I had some issues with that. It's been pretty solid now for a while. That's not what it's called. It's called nav mesh polygon area data. Polygons. Add polygon. Yeah, if you have any questions, I will get them in a second. I just want to very quickly do this because it's not very interesting stuff, and I want to kind of get this done so we can start playing around with this thing. Polygon index, polygon, and yeah, polygon as well, like so. Let's see if this compiles this file to begin with. I had some other game projects I was working on that never got completed. Right. So started around 2022. I started Traction Point in 2023, about 2 years ago. But a lot of the stuff in Traction Point, in like the actual, you know, Zig code and everything, is stuff that I've ported over from C++ from the slide project to Zig. So some of that stuff has been really sort of quick to do, and some of it hasn't. Right, so we have editing mode, points, circuits. We want to rename that editing mode polygons. Right. Still have some circuit text there. And then we want to get rid of the testing completely. We don't have any testing stuff here. So get rid of that. And that's supposed to be polygons. Circuit map editor, polygon area editor. Let's actually call it nav mesh polygon area editor. All right. And we don't have that. And you can see some of this code is like extremely basic to the point of being like repetitive sometimes. Just keep your code simple. I wrote this about 3 years ago, and I haven't looked at it since, and I can kind of read it quite easily because it's so basic. That's my advice to you. Okay, so now we can't actually compile this thing now because this thing is running. So let's actually do this. Hit a key combination, and it sort of like unloads the backend, as I call it. It shuts down the game application that was running there, but it keeps this editor open. We can't actually edit anything here. And if I click here now, it will load that thing back up. But now that it's actually shut down, we can build this thing. So it's just sort of just like a shortcut if you need to rebuild the code. And Alden says my engine is incredibly simplistic in comparison. Well, I don't view that as a negative, at least. I hope you don't do either. It's also built directly to the requirements of the game we're working on. You know, that is what happens when you use an engine for long enough. Originally, this was also built to the specifications of whatever I was working on at the time, and that's kind of like the only sensible way to build something. You know, you shouldn't build an engine just to build an engine. You should build an engine to make a game, or then you should just make a game, not build an engine. Even better. Right, so we can of course still do this. Click, 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 and we have the thing. And that's nice. But what if we now shut this thing down and we go into our means. Go into our assets browser here and we add something called a blueprint. AI blueprints. They need to be on the AI, on the engine level. So AI nav mesh area. Here we have the area and we have the area path. These are the things that we've actually been looking at for the roads so far, right? So here we can now add AI nav mesh polygon area as a new one. And we can see here that the area path, for example, it's exposed to the editor, yes, but it's also set as editor only. So this thing will never be used in the actual game. And then it has just the one component, which is the area path, and it's only have something called the creation policy, which is like client server, kind of self-explanatory. These are like in the running game. And then we have level editor and asset browser preview, so that would be this window. Focus was a bit wonky there. So polygon area. We've got a transform component, but I don't think we need that. I don't think we need a transform component, do we? Let's go into slide and see. So this is the other game projects. We can go into blueprints here. I think it's probably an in AI. Oh, it does have a transform. Why does it have a transform? Do we need the transform for something? Transform. I don't think we need a transform for this guy. Like some things need transform components, obviously. If you have a mesh, then it needs a transform component because it needs to know where in the world it is. But this thing doesn't seem to reference any transform components at all, so I'm not going to create one. Let's just take that away. Take it away, and then we can copy the full name of this component. That guy. The full name would be basis : and then that. Let's add a component. Basis. You can see here that we have a list of registered components. We haven't registered that, but it doesn't really matter. Polygon area, we can call it. And it complains that it doesn't know what it is because we haven't registered. That's fine. Just trust me, bro. It'll be fine. Level editor, not on the client, not on the server. Also not in the asset browser preview. We don't need any asset browser preview for this. Editor only is good. No base type, no placement offset. It's all good. All right. So now let's see what happens. Go to means. I'm going to use another air. Oh, what? That's probably because we haven't registered it with that name. Yeah, you can see that we need the basis there. Let's add basis here. Basis. So this first this first macro parameter gets stringified. So this thing is what we will want to use verbatim. Now we should be able to see it here in this polygon, mesh polygon area. It doesn't have any thumbnail, of course, because there's really nothing visual about it in a thumbnail sense. Let's go to depot, which is a work in progress level, but it's much faster to actually open, like so. So now we don't have any nav meshes here yet, but it doesn't matter because this thing doesn't do anything with nav meshes yet. So if we create one of these guys, we do get the polygon area, we get the edit state, and look at this. Now we can do points and polygons. So again, I can start clicking these things. Isn't that cool? And I should be able to go into the polygons, add a new polygon, and assign points to it. Look at that. And then I should be able to go here, add a few more points, reassign these points if I want to. Come on. There we go. And then I can go back here and I can select one of these and I can move them if we want to. So yeah, the visualization here leaves a little bit to be desired, but apart from that, and that is of course something that we can change later on. I think this is pretty much exactly what we want, because like we can model these kinds of places kind of nicely with this. The only perhaps annoying thing is that if you want to add a new point here, you need to essentially like reassign all of the points. Maybe that's something that we can do later on as well, if that turns out to be an issue. Cool. And then we can click this, accept edit. Because again, the editor has no idea what we're doing. When we click edit state here, we're essentially telling the editor, hey, we're now gonna start messing with this object internally. You know, don't worry about any key presses or mouse movements. The only thing we want the editor to manage here is the movement of the camera. And so then when you click, you can either cancel the editor, you can click accept edit. And now we're back in normal editor mode. And now you can see that like if we hover on things, it shows the highlight for them again, because now we're back in just the normal editor mode. So here's the two edits that we made to that. We can undo and redo them back and forth. That's pretty cool. If we save this thing and then we open it up again, it should still be there. Let's make sure that saving works. So now if we select it from here, there we go. Here's our polygon. Not bad. Very cool, very cool. Something I was meaning to do. What was it? I don't quite remember anymore. Yes, it was this thing. Export level, like I mentioned previously, this guy gets called in such a way that, like, if we want to actually bring data that this component has produced somehow into the final running game, we can do it with this export level thing. We don't want that, and so we can just take that away, and that also means that we can take one of these parameters, I don't remember which one. Has exposed properties, yes. Needs export, false. That is false. Has editor state, yes. So the second one can be set to false, because we don't actually produce anything for the final running game. We just give things to the nav mesh generation, and then the nav mesh is the one that actually produces things for the final running game, if that makes sense. Alrighty then. At this point, maybe I should post the link to the Discord in the chat. We've actually had a few new joiners here. Welcome everyone. I'm glad to have you. Still, let's post the Discord link in the chat so that it is readily available. Hey Matt, welcome back. Today we're doing a little bit of engine development here, specifically on the AI side, specifically on the nav mesh side. And so we have a custom tool here in the editor. This is something that, like, some of you may remember when I added the grass painting. This stuff here. This uses the same thing, and that's why when you actually paint grass onto the ground here, like this, you can see this editing grass shell grass 1 grass editor. That's the name that's the full name of the grass component. And again, we have this ImGUI window here because this is another example of a tool that the editor has no idea what it's actually doing. All the logic for that stuff is written in C++. The editor just deals with the fact that we are editing it. And so I added this new, or well, I ported this from the previous game project, a system where I can add these points. I can move them around, and I can specify these kinds of like polygons with them that we can then use to lay out nav mesh areas that are kind of tricky to represent with just like boxes or splines. That's the idea. So then, how would we actually hook this into the AI or the nav mesh generation? And that's also incredibly basic. That system should perhaps get a bit of a fresh coat of paint at some point. But so far it is incredibly basic. We have something called a nav mesh builder component, probably. So we have nav mesh area. So far we have 2 areas that can be hooked into this thing. Find nav mesh area objects. And we can see that we don't even like have a system to register new type of areas. This thing just goes through and finds all the areas that it is interested in. So nav mesh area component and nav mesh area path component. We just have quite simply a for loop that runs through and finds all instances of those. So we should add our new component here. But to be able to do that, we need to look at nav mesh area. So this is the interface that the system needs us to implement. So contains polygon is like, okay, are we now inside this area? and then get area type. So that tells me that these other components implement that somehow. So if we have area component, this is the simplest one. Yeah, it's a game object component, but it implements this nav mesh area as well. So let's add this here. We need the AI types here as well. Public basis nav mesh area. I'm just going to copy paste these guys from the other one. So contains polygon is something that's implemented in the CPP file. Nav mesh area is just implemented here. We need an area type. And let's actually get that draw when unselected as well. Actually, no, let's not do that. I can do that later. But yeah, we want that guy. So nav mesh area type. This is an enum, which specifies all of the different types of area this can be. And specifically, we're now interested in road and road minor, because those are the two ones that are used by the traction point vehicles. But we need to be able to select that somehow, and that is where this property map now comes in. So I'm just going to copy paste that as well. It's a bit macro heavy, this system, but still, again, we need to specify here that yes, this is an enum with some options. The type is this. The member is this area area type. Default is ground. This is just a version number, which is currently always 1. And then we can set some more options here in string form. These get sent to the editor. So the description here is just a type of nav mesh area. So let's do the same thing again. I'm going to unload the backend here. I'm going to come back to the editor in a bit. Now that we have this, we should be able to see this in the inspector. But before we do that, though, I'm going to have to implement this contains polygon here. So return false. This is a to-do for us. And now we can hook this into the builder, nav mesh builder, which is here. Include game object components and nav mesh polygon area component. And we can quite simply do this. Polygon area. Like so. Oh, there we go. Yeah, you can see I don't really use auto and things like that, even though it would arguably be nicer to use it there. And we can make these a little shorter. Like this. I'm not very proud of this nav mesh builder code. It's like an amalgamation of a bunch of recast tutorials and some of my other stuff thrown on top. And it can be a little confusing sometimes. Anyway, that is that. So now if we go back here and we select that area of ours, you can see now we have an area type here. Now we can set it to whatever we want. Most likely road here, if this is the shape. now, of course, it is the question of like how do we determine if something is inside this or not. And I think like the easiest way to do that is to construct a bunch of planes that that we compare. You know, is it in front of the plane or behind the plane? That sort of thing. And then we essentially iterate over all the faces of this. And we might want to have some sort of max height and min height, so that we get sort of a proper volume here. And then the system can query this thing to see if a thing is inside it or not. But it is getting pretty late here, so I think that is something for tomorrow me to deal with a bit of renewed energy. This was nice because now we have essentially the editor side of this all done. One final thing. I improved. This is not really, doesn't necessarily concern or show to you guys directly, but some of you know that I have been working on a mod support system. So this flying scout here, which has these jet engines on the back, this is a mod which well, quite simply adds a jetpack to the back of the car. This completely breaks the campaign, because the campaign is in many ways about getting into places that are kind of difficult to reach. And if you can fly over obstacles, then it kind of just breaks it. But it doesn't really matter. One of the main sort of selling points of this game is that it's supposed to be moddable, and you're supposed to be able to create new content yourself and all of that, blah 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 blah. And if we go here to the mod manager, we can see that we have Flying Scout here. This guy is actually a WebAssembly module that we are loading. Mods can be either native code or WebAssembly. I did quite a bit of WASM fixes and stuff yesterday and earlier today, and I'm happy to say that we can now run this simple mod without any sort of WASI support, which is the WebAssembly system interface, and that just makes a whole lot of things simpler. So now we can run it as a so-called freestanding module, compile it with Zig freestanding, and that is very cool. We're getting closer all the time to just having a system which is sort of robust enough for you guys to mess around with. Again, like I mentioned previously, mod support won't come for pre-alpha 2, just because I won't have time to like make the actual SDK for you guys so that it's you know, easy to use and all of that. But I'm pretty confident that I will be able to get this for you in pre-alpha 3, which should be out like at the end of summer or early fall. Maybe make the modding a reward for completing the campaign. Well, I kind of want to make the modding a reward for anyone just wanting to try out the game, if I'm being honest here, right? If I can get, I'm not necessarily expecting that to happen, but if I get some sort of modding community going for this game, even if people haven't bought the game, you know, I already consider that a win for myself. So way before any of you guys will have to pay any sort of money for this game, I want you to be able to mod it and mess around with it, and then maybe if you like it, as a thank you, you can buy the game and get the campaign and everything. I haven't figured out the business model yet, but that is sort of my feeling. Yeah, you can see this mod is super wonky. These jet engines don't have any collisions, for example, or anything like that, because it was literally made in like a few hours. You can just drive through the cliffs with those engines. The game also becomes self-evolving in a way. Absolutely, yeah. I mean, this stuff is just like super fascinating to me. When people make things for products that have not necessarily, you know, gotten the end of life treatment, but like people just add things that the developers never intended, and in many cases it means that like once the game goes offline, or you know, in this case this won't be a live service, this will just be a game that I will probably just keep updating and maintaining in one form or another, because it's not super expensive for me to do that. But even after I do that, people can essentially keep adding things to it. Now I flew off the map. Yeah, this map is very in progress still, as I'm sure you can see. But yeah, that would be that. I think I'm gonna basically end today's stream here. So tomorrow I will take a stab at this AI business once more, and we should get this guy to behave more rationally in the demo level. Modding wise, do you think we'll get access to the level editing tools as well? Absolutely, but not necessarily immediately. Yeah, it's probably best that I don't promise anything to you guys. The thing that I can say is that I hope to give you all of the tools. Or, you know, all of the tools that you might sensibly want to use. So that would be, you know, the material editor, this guy, so that you can create materials easily with this. You would get the particle effect tool. And for those who haven't seen, this is also a node-based thing. So here we have the smokestack from the other level, for example. It's created by this monstrous node graph here. I'd like to give you this one. Then you would get the Nemo, which is sort of like the world fact slash scripting tool. So here's the script for the mission. We looked at this yesterday. This is a little trickier to make available to you guys, if we're being honest here, because what this thing actually produces is like a file that let's see, where is actually output folder, right? Okay. Yeah, so it produces like a file that goes here, Nemo bin. So this thing is called Nemo, so Nemo binary. This kind of specifies the whole sort of structure of the campaign and all of that. So it does need a little bit of plumbing to make this thing available to you guys, but I do want to do it, so I'm gonna have to somehow figure out how to do that. Same thing goes with the audio tool. This should definitely be available to you guys. But the way this is currently set up is that like we have a lot of plumbing that actually happens here inside of the tool. You know, we have the buses, for example, the music bus. And these, a few streams ago, we actually hooked this up to like the options menu, so that you can select the volume for the music, for example, and that refers specifically to this bus here. And so I want to make this available to you as well. However, I need to make some sort of like additive project support for this tool. So this is also a node-based tool, unsurprisingly perhaps. You know, it produces sounds quite simply. And if I make this available to you, I will have to make some sort of additive project support so that you can take the project that is already in the game and you can create sort of like an additive project, because I don't want you guys to mess with these buses, for example, because it will break the whole audio system. But then I do want you to be able to create new controls or new events. That sort of stuff. Yep, then we have the asset server. This one you actually probably will need to get as the very first thing. The asset server, as this is the thing that like converts the assets into actual resources that the game can load. So this thing is actually going to have to be available to you from day one when you get the modding SDK. Then you have the asset browser. This is not strictly needed, but it can be kind of nice to have. I'm gonna have to figure out if we can actually make this available to you somehow, or if it is sort of too tightly tied into just my way of working on this machine, or my machines. The level editor itself, this should actually not be super tricky to use, but you know, I'm not planning on necessarily shipping all the assets to you guys. Just like a subset of the assets that you can use to create mods and whatever. And this thing might get confused if it can't get access to all the assets. So there might have to be some sort of like limited mode that we can run this thing in. Limited just in the sense that like it has less assets to work with in like their source form. And you might be wondering, why don't I give you full access to all the assets? Well, I can't legally. Like I have like a font, for example, which I am not legally allowed to give you the true type font. No matter how much I would like to do that, I can't do that. So you know, that's life. It's not that I don't want to give you everything I have, just that I can't do that. The monitor is also kind of handy. This is mostly a profiler. It looks like this. We can probably actually connect it to the running game. No, it's not that one. I don't remember my port numbers anymore. Here we go. Trampoline main loop iteration. So here, if we now we have this actually connected to the editor. So we can see the frame times here, for example, blah blah blah. If we go look at something way off in the distance here, you can perhaps see. Oh, we need to, by the way, we need to untick the frame, the cap here. Now we can see that like, okay, the frame times are very small. We're running at 1,000 frames here, and then when we look at things again, you can see it sort of fluctuate a bit more here. And then we can go like, oh, okay, I want to know what happens here. So then we can stop the session, and we can even just close that thing down. And now we can go and inspect here. What is actually happening here? Oh, it is the rendering that is getting slower. I wonder what that might be, because what is the reason for that? And then you can dig into these things. And yeah, I want to give you this as well. It's very handy. We also have something called hot values here, which is not necessarily super well or widely used these days, but these are essentially like tweakable values that you can just specify in code. There might be something interesting here. Time track render, prototype crane. Yeah, to be honest, I don't use this a whole lot anymore. But you can like tweak gameplay through these if you want to. For the asset license issue, the way it works in our case is that the editor can both read and work with data stored and loose files and from a pack file. Yes, that is pretty much exactly how it works in this case as well. The editor technically works with something called resource packs. A resource pack might be a pack file, or it might be something else. And if you're running off the asset server, as we have been doing here, you can see here I've run the game or the editor or one of the previews 473 times since this instance was started. Because it just increments it by 1 every time. And in here, each one of these folders is a resource pack. These underscore are sort of like part of the system, so you shouldn't really mess with those typically. But all of these folders here are resource packs, and in packaged builds, these typically become pack files. And so it should already be possible with a little bit of elbow grease to make it so that you can have resource packs that are pack files, and then resource packs that are loose files. In fact, you can already run the game with 2 different types of pack files. So here's pre-alpha 1 for those of you who are interested in what this looks like. This is the thing that you can join the Discord and you can download this right now. It's available to you. And with this you get a bunch of BP4 files. So these are pack files. There's also an older pack file format which I still support, which is called just pack, P-A-K. And you can already mix and match pack files, and the system works sort of can work with both of them. Having it work with the asset server as well as pack files will require a little bit more work though, so that's something to look into. I need to think about an ideal communication that will be the bridge C# and C++. Yeah, you need to figure out how you want that to be sort of like how that interface should look like to your code, to your game code. I'm just assuming you're making a game here. You might be making something completely different, but let's say if you're making a game, you need to somehow decide on how the interface should look towards that, and then how the actual transport is handled is something that you can switch under the covers without having to necessarily change the interface. I'm going to show you actually that just as a last little technical thing here. I'm just going to go get a glass of water, so I'll just be back in like 10 seconds. Alright, I've been yapping here for 2 hours now, so throat getting kind of dry. I have something called Net API. This is a very simple little interface. This is based actually on eNet. So I think eNet was mentioned here previously in the stream. I use eNet actually for my networking. And this is kind of like based on eNet. It uses sort of like eNet terminology, but it is not in itself eNet. Right, so you have a host, you have events, and you have peers. So host is sort of like, you know, this is the thing that we are currently sort of like the local node, if you wish. If you have 2 things on the network talking to each other, they both have a host, and the host is sort of like the local thing. That's like, you know, the representation of their themselves on the network, and then peers are like the representation of their peers, of the other ones on the network. So you can have a peer and you can send a packet to it, and then in the host you have an update function, and the update can have a result, and it can be like an event that happens. An event can be, for example, that we got a packet received, like this, and then you have the data here and the data length. And so this is how the networking works on a sort of like a low level basis. Then the RPC system is just, is built on top of this thing. So you should be able to completely separate your RPC. If indeed you want to go with RPCs, you should be able to separate that completely from the low level stuff. I also have something else beside RPCs called pipes, which is just like a named connection between 2 points, and you can just like dump things into it. It's kind of like a stream in a sense, and it's also sitting on top of this thing. And then so this is just the interface. As you can see, we have virtual functions here. Everything is virtual essentially, except for some things that aren't. Then we have two backends. So we have a backend for eNet, and now we're like actually dealing with networking things, right? So now we have a peer eNet, which derives from peer, a host eNet, which derives from host, and so on. And I'm not saying necessarily you should do it like this. I'm well aware that like virtual functions aren't the most performant these days, and a lot of people don't like object-oriented code. I have a certain fondness for it, but yes, just like this is pretty old code at this point. The concepts are still relevant. So here we actually have an eNet host under the host eNet, which implements my host, and we have a eNet peer under the peer eNet thing. And so when you actually send a packet to a peer, here we are actually eventually calling eNet peer send. This is the thing that then actually puts it on the wire, so to speak. Are your pipes like WebSockets? I don't actually know how WebSockets work. I've never used them. I can show you. There's so many things to show. I don't know if anyone wants to see this. You're free to leave at any point. I can show you the pipes quickly after this. I'm gonna end soon anyway, so it doesn't really matter. Then we have the so-called backend memcopy, which is the memcopy backend is used if you just start the game. You want to play single player, and you don't care about any sort of networking. We're still gonna run a client and a server for you. One benefit of doing that is that like multiplayer code can be used for the single player as well, which means that multiplayer code in general tends to be more robust because it's actually using client and server. Another thing that is handy is that we can run client and server on different threads without having them like share data or really have to sync with one another. So we can do multi-threading that way, or at least like bi-threading, I guess. But this is another backend. We're not really interested in actually communicating over the network. So we have a peer, which is a peer memcopy, and we have a peer, which is a host, which is a host memcopy. And send packet here actually doesn't send anything to the network at all. Instead, it has something called a shared store, which is like a mutex locked piece of memory. Send packet in the memcopy shared store. And use the Benafor, which is like a pretty fast, lightweight locking mechanism if you don't have a lot of contention. And so it just literally memcopies. That's why it's called memcopy. Memcopies it into a piece of data that the other can then go and have a look at. So this is just to show that like I could if we're talking about, for example, networking versus something like pinvoke, these things could be represented both by this kind of interface. So I wouldn't really be super stressed about like if you want to go networking or not. you should just abstract them at a level where it sort of makes sense. Are my pipes like WebSockets? My pipes look like this. Where should I show it? How should I show it? I think the what's it called? It's called probably cable magnet assembly, isn't it? Yes. So we're in Zig now. Pipes are a somewhat recent addition to the engine. I haven't really used them from C++ ever. So that's why I'm showing you the Zig side now, because this is the place where they're actually used. So we have a cable visualization. It is essentially like, let's just run the game. And I'm going to show you, it's got one of these small test levels here. Let's put a mother in here. Boop. So this thing has a crane, as I'm sure you're well aware. And the crane has a cable which is simulated actually on the server. This thing here, which flails around kind of annoyingly violently often. This cable is simulated on the server, but we want to display it on the client. And so the way it is done is that we have a pipe set up for the cable, where we can just like continuously push new positions where all of this is in the world, so that we can render the mesh. Let's see if we can actually, yeah, you can see here that it's kind of made up of like almost like sausages on a string like this, out of individual bodies, and all of these transforms need to be sent over to the client so that the client can then render this nice cable for us here. And so cable visualization pipe. We create a pipe, or we register a pipe, we give it a name. If I remember correctly, that name needs to be unique within the component that creates it. So this is a component, just like we've been messing around with components in C++, all stream. This is actually not a component, now that I think about it, but it does belong to a component, and the component context that we're getting here, it actually belongs to an avatar tracking component. This essentially just means that this crane cable magnet assembly needs to be a member of a component, because we need to get this context from somewhere. This is almost sort of like passing the base class to something. If you need a base class to create something, then you know that, okay, you need to actually add this to a component so that you can get the component's base class. We don't have base classes in Zig, but the idea is the same. Anyway, we need to give it a name. Name can be essentially anything. It gets hashed. We don't send the string over the network or anything like that. Direction is server to client. It's not reliable because we just keep spamming this guy over and over with things. Here in tick, let's see, what do we do? Right, we initialize a stream to a visualization buffer. This is a U8, so this is sort of like a byte buffer in Zig. If you aren't familiar with how Zig works, but we get a stream, and then we just put things into the stream. So here we put vector trees and quaternions. Actually, probably this one, right? Trying to remember how this works. We put an AABB. I don't honestly remember anymore. We're pushing U32s here to it somehow. That's interesting. Oh, you know what? Okay, yeah. Yeah, it already contains the stuff here. Then we just add some more to it here at the end. Yes, cable visualization buffer. Yeah, exactly. The point is, at the end of all of this, write to pipe is here. So we push the data to pipe, and this is we sort of cap it with the cursor position. So this is a slice in Zig, so it already at this point knows its length, right? And then sometimes later on we have on pipe data received, and we actually assert that the pipe that we receive data on is the cable visualization pipe, because we don't actually have any other ones. We also assert that we are on the client here, because we should never receive anything on the server, right? And so that's how pipes work. Pretty simple stuff. Rightio. Anyway, I think we are pretty much done for today. Thanks everyone who came to hang out. This was a fun stream, lots of discussion going on. And hopefully we can continue it later. If you want to play the game, join the Discord. You can play an admittedly pretty old version of it today, and in a week you will be able to play a new version. Pre-Alpha 2 will be out in a week. And then in about a couple of months we should have Pre-Alpha 3. As always, remember to like, subscribe, like the video, click all the buttons. You know the drill. Have an excellent evening, everyone. Hope to see you next time.